Let me introduce myself. My name is Alexey. Call me Alexey. I founded the company Bitquery back in 2018 to analyze the blockchain data. Till now, we're working on the same area. This is very, very interesting data analytics space. We made a lot of success here, and there are still a lot of open opportunities in this space. So today, I want to just share with you like some interesting facts about the blockchain, like about the data. So I want to share that with you. I welcome all questions that you have. Just ask during the session or after that. So who of you knows what is the blockchain, first of all? Okay, almost everyone. Who can describe it in a couple words? Okay, can you?
Безопасная технология хранения цепочек транзакций.
Okay. Okay, thank you. It's as a secure way of storing transactions, yes? Any other definitions?
It's the sequence of the transactions in blocks.
Sequence of the transactions in blocks. Decentralized. Okay.
Distributed ledger.
Distributed ledger. Okay. So your definition is almost all of them, like mentioned, transactions. That's cool. Actually, I see the blockchain kind of slightly different as a database. So consider, like you can define the database as place where a computer stores the sequence of transactions. Is it correct definition? What do you think? Like what is the difference between the database and the blockchain? You cannot change the history, while in actually database you can. In database there is such thing as a log, which you cannot change in any way. So you can consider blockchain as the log of the database, yes? And what's then the database? The database is the state which is stored in the nodes. So what you didn't mention, and it's very important that somebody said decentralized. What it means? It means that it's not just a database, it's thousands of computers around the world who stores the same data, each of them. And that's very important. So this database, unlike the databases that you probably work in enterprises, it's have a huge replication factor, like 1,000, 10,000 or million times the same information stored on the world. Yes. So it's kind of very inefficient. Why the blockchain is doing that? For what? Reservation. It's both. Actually, it's both. So the both answers are correct, I think. So the main reason actually that everyone can confirm the correctness of the data, the validity. That's why everyone needed a copy of the data stored in the computer, that it can prove to others that I have this history of transactions. So I can prove to you that this history is correct. That's why it needs to be replicated over whole globe in many, many computers. But what's important in our today story is that the blockchain is essentially a database. So you can look at this as similar to what you typically consider from the data. What you have in database, you have transactions, you have records, you have other like facts. If you consider this as a data warehouse, you have some facts, you have some aggregates, so on. So yes, blockchain is a database. What features of this database we have? So I wrote here some very common features. First of all, it's very open. Everyone can use it. It has open source code. It has open source data, which is important for our today conversation. it's decentralized means that it doesn't run on any particular computer, so nobody can stop it. Nobody can, say, modify the data in the past or censorship. The data is also quite impossible. So whatever you write to the blockchain, it appears forever. Nobody can censor it. By the way, there are some quite funny facts that sometimes people write us, like from the lawyers, companies, to remove something from our data. We're saying that it's just kind of impossible because it's written in the blockchain, yes? But there are precedents on that. What is eventual consistent? Some of them working with some eventual consistent databases? Do you have examples? If it is the same, it's not eventual. Eventual means that at any particular point of time, you don't have the same data on the nodes. So, in other words, if somebody sends you Bitcoin and you see it on your node, it doesn't mean 100% that you received it. With time, it gets more and more confident. With new blocks, say, added to the blockchain, you're more and more confident. And eventually, say, after 6 blocks, you can say that I'm kind of sure that I received that Bitcoins. But actually, in Bitcoin, you're never sure that you own it. It's very important. Fact that it's never finalized. Also, what is interesting that the consensus in the blockchain means agreement between the nodes about the data, yes? And mostly, it also affects the time. The time is a very important factor in the blockchain. People in blockchain ecosystem, they measure in time by blocks. And I think they will, like, just saying that, how old are you? I am 6 million Bitcoin blocks old. Yes, so it was before the block number 2 millions. Yes, it will be funny if somebody will say that, but actually they do that. They measure time in blockchain. Yes, so blockchain is kind of measure of time as well, not just of money. This is, of course, cryptographically proven. It's common thing that you sign on transactions. You can prove that you signed it. And also what is important today in our conversation, that it's driven by protocols. What does it mean? Unlike, say, traditional databases, where you get the code from, say, MySQL or Oracle, you rely on this code only. You set up a new MySQL version, it can work completely different from the previous version. Nobody cares about that because it's your installation. In blockchain, you cannot change only your code on your node because it will not participate in the network. Network will reject your node. Yes, so all the nodes must run same protocol. That's why it's rather hard to modify this protocol, and every data in the blockchain is actually driven by protocol as well. So this is an important feature that we will see this on data as well. One question I have to you, related to the nature of data. What do you think these two graphs shows us? 1 second, I will make it a bit like this is the years, yes, on the x-axis. And these are two graphs. What do you think it is? Yeah, one blue one is price of Ethereum in dollars, yes. And the yellow looks very similar, but it's not. It is the transaction count per day in Ethereum, in the blockchain. So it looks very similar for some reason. I will not analyze why it's similar. It's not my job. It's analyst's job. I'm not analyst. But we today will talk only about the yellow type of graphs. We will not touch the, mostly touch the questions about money in the blockchain, like how many Bitcoin costs. So we analyze just on-chain activity of people in the blockchain, what they do, and how the blockchain helps them, what is the statistics, and so on. Okay, so how we can... Oh, by the way, if the blockchain is a database, can we say that internet is the database too?
Sure.
Sure. So how to query the internet?
Website.
Huh?
Website.
How?
Domain name system.
Huh?
Domain name system.
But it's not querying information, it's just finding the website. How do you query internet? But what? Yes, exactly. We query internet by Google, not by SQL. Today we will also not use in SQL. We will use GraphQL to query blockchain data. So let's start with some simple example. So I cannot type without holding the microphone. I can type the query. For example, I want to know what was the biggest transaction of Bitcoin today. Yes, I select the Bitcoin. I select here the transactions. Date is today. It's quite, who knows, by the way, who knows GraphQL in there? Not so much. So it's the same as SQL, but it's kind of different brackets. Otherwise, it's quite similar. I will probably, if I have time, I will explain at the end why we use GraphQL, but it's a long topic. I will not stop it, that's very far. But so we have the count transaction. Let's say I have the maximum of input value. It will be like kind of close to, we'll make it bigger. Yes. So today the transfer was 9,000 Bitcoins in one transaction. It is multiplied to 50,000, quite a lot. So now we can ask different questions. Say, how do you think how many fees people paying for transactions in Bitcoin? Maximum. Thousands of dollars. Say, let's take it off today. Maximum of I can query this way, but I can query it another way. Say, gas value in total. Fee value. So in total today, people spent 39 Bitcoins for transaction in one day.
This is a maximum? Or?
No, this is not maximum. Maximum, I need to do this different calculate maximum. And maximum is 0.04. It is still, it's quite a lot. So it's $2,000. How much you thinking people paying maximum like in whole history? I don't know, but we can add here the date. Say the date and see. Say after, say by this year, say from the 1st of January. We have some numbers. Now we can display, like it's a bit, fee value. Yeah, so the top, so the top here was at 23rd of January, the day of Soviet Army. So somebody spent 0.74, it's $40,000. Yes, for one transaction. It's because I calculate here the maximum over the date, over the date of the fee. Then this, so this is quite a lot, but this is not total maximum. I know that, say, in record number in Ethereum is approximately $90 million for one transaction. Why do you think people paying so much money? Hmm?
To be faster.
Why they need to be faster?
Because time is money.
Ah?
Because time is money.
Time is money. Actually, I think that the case of $90 million in Ethereum was kind of mistake of the robot. It's a bug in software. I think so. But this, as you see, by the way, the distribution is quite high. So many people every day paying more than $1,000 per one transfer. The more money he pays, the more confident he has that it will be put in the nearest block to be mined. It will be faster. Yes, it's correct that the time matters here. And also, they want to incentivize miners. So the whole story around the Bitcoins and Ethereum is why miners should do mining. And the reason is not to actually produce new coins. That's true, but the real incentive is to drive the whole network. And this is very important. This way, actually, you can query information up to any level of granularity. Now we query the whole data set of Bitcoin. We can query much smaller or bigger, or we can query different blockchains here. So you have the list that you can select because the selection right now, they're actively developed approximately maybe 300 different blockchain protocols. It means that there are many developers involved in the ecosystem of the blockchain. And here I tried to collect different data sets. So essentially, I put the network as a variable here to be able to write once the function that you can run sequentially to get data about different blockchains. I want to compare different blockchains just by the number of transactions per by time, because it shows the dynamics. Why I selected specifically transactions? Because first of all, you mentioned the transactions from the very beginning, and that's absolutely natural. Transactions are the most important part of the blockchain, and measuring them is a good measure to understand the activity of users in the blockchain, what they're doing, and how often. So I collected here a lot of data sets. You see all these names, like Dogecoin, Terra, Bitcoin SV, Ethereum, Matic, Tron, and so on, is the name of different blockchains. And let me first do this, because I want to remove Solana from this picture. I actually maybe start with removing everything except Bitcoin to show the scale. Because Bitcoin was the first one, and it created some baseline for everyone else. So Bitcoin SV. Okay, so Bitcoin itself. Let's remove Bitcoin SV from here because I don't need it. how to do that. Merge. Maybe this way. I'm not good professional in. Actually, I opened this Python only for this presentation, so I'm not. Probably you're much better in this. So this is transaction, just Bitcoin. You see that it spends a lot of time. It's grown, but then it's pretty steady. Why you think it's not growing? Yes. So Bitcoin has technological limitation of the number of transactions it can process, and it's a big deal. So everyone criticizes Bitcoin for that. There are two critics about Bitcoin, about this fact and about the electricity that miners consume and prevent our nature to grow better, like trees and everything else. But actually, nobody believes that Bitcoin can grow significantly in magnitude because of the fact that it has technological limitation. Yes, we get back now to the merge. After Bitcoin, there appears a lot of blockchains. I will select them by one. Dogecoin, like this kind, which actually replicas of Bitcoin, who tries to, like they pretended to be better Bitcoin, but actually they were not. So you see that Litecoin here in color brown has more transactions, maybe 10 times more than Bitcoin, but still it's not a big deal. So all these attempts to replicate Bitcoin essentially were not serious because they use the same technology base. They only tweaking it up, like faster block time versus security versus something else. But then after that, there were appeared some other blockchain. First of all, Ethereum. Let's add just Ethereum here. Ethereum, it's something broken here. I don't know why. Let me check. Probably Ethereum lost from the data set. Not sure why it doesn't show, but actually Ethereum made quite significant improvement over the Bitcoin, but not quite a lot. If I add the, say, BSC, EOS, say these two, we will see that I think it doesn't correctly show maybe the colors, I don't know. But together, they made approximately like from, I would say from 2 to 6, 60 million transactions per day. Yes, it's quite bigger than Bitcoin. Bitcoin shows like 500,000 per day, so it's much bigger. And then if I add all others blockchains, except Solana, I don't want Solana. So you see that the order of magnitude raised another 10 times. So it now it's 100 million transactions per day. Yes. So they in total gives like approximately these figures. And you see that they together they constitute the growth of transactions quite a lot. Yes. So the evolution of the blockchains mainly caused by the evolution of the different protocols, not just how people actively use Bitcoin or how they use Ethereum, because the bandwidth of each protocol is quite limited till now. Solana, why I commented Solana? Because Solana is quite different. If I place here Solana, I will get immediately. So all this is Solana. Solana uses the new consensus algorithm, so-called proof of history, which significantly expands the bandwidth of the blockchain, significantly. And I think that in the future, what we will see is we will see development of the protocols that will raise this rate on 10, 100, and 1,000 times. So blockchain will be developed not as a development of current protocols, it's development of future protocols. It's quite different from internet. Internet, when HTTP was invented, till now we're still using HTTP. And till now we use TCP/IP, and essentially the same stack that used 20 years ago, we're still on the same stack. With the blockchain, it's not the same. So in 20 years, we will use different protocols in the blockchain rather than we do now. And one of the reasons is this graph, because Bitcoin here is not visible. It's on the zero line. It's not even like close to the figures that in total these protocols gives. Oh yes, and this is independently This is internet users per year. So I specifically placed it here because I'm not sure where we are. So if you take the period, I think we even before 2005 in this graph, when we compare the dynamics of blockchain and dynamics of internet, I think we're not yet even on 2005. We're somewhere in the start of 1990, of somewhere there. So because this graph, it shows that the potential is quite high, but we don't see like a good distribution between different protocols, and we're just in the very beginning. That's impression that we have from here. I intentionally didn't put here the graph of the price of, say, Bitcoin, because it goes up and down. It gradually going up, but it doesn't reflect the dynamics of the ecosystem itself. So, from my point of view, the dynamics of development is independent from the adoption of cryptocurrency at all, and from of these prices for Bitcoin. Also, it's quite independent thing. Of course, for investors, it's dependent. Investors looks at all these figures, but from a technological point of view, it's absolutely independent processes. Yes, I put here some graph. By the way, this presentation, you can run it. There is instruction which is on the GitHub, so you can run it yourself. All this data can be requeried. You can get API key, you can requery it and rebuild it if you want. I will not describe this because it shows just that blockchain transaction has no relation with the market cap. Market cap is, say, capitalization of cryptocurrency, something like that. So it's not related. So there are blockchains that has very small transaction count with very good transaction per second, say, and adopted by users, and vice versa. It's absolutely unrelated. This is graph that probably interesting to just see. Let me maybe scale it. It's uniques by day. In internet, when you estimate the website, what you do, you count unique users per month. It's a common metrics of success, yes? The same metrics can be applied very easily in blockchain. So this is the query of counting unique smart contracts per day used in Ethereum. You can query the same thing with users. So users is unique senders of transfers. You can also calculate unique senders for transactions. It will be similar numbers, but slightly different. So you can query, it's the same as you do for the website, even much easier, actually. So you can query your user base. And you see that this is just Ethereum. It's users and unique smart contracts, and it's measured in millions. So it gives you some impression how big is Ethereum. It's not big. So you see that the website with 4 million unique users per day, it's not quite big website. No, it's not small, but it's not Google. It even not close to it. Maybe not in 100 top websites. So by and also by users, here I mean just addresses. It's not equal to users exactly, because one user may have as many addresses as it wants. So it's rather hard to count exact users. But say in order of magnitude, it probably makes sense. And here I collected some very questionable numbers, which I mostly invented from my head. By the way, getting internet statistics appeared to be pretty hard for me to find the numbers. For example, what is the daily page views in internet overall? I couldn't find this number at all. Maybe somebody knows that, but I combined this 100 billions from estimate that I have from similar web. I looked at Google, Facebook, and so on. For blockchain, it's easy to count the transactions. For internet, it's very hard to get any statistics. It only big companies knows the data about internet, while in blockchain, actually anyone can query it. It's a big difference. It means that in internet, only Facebook, Google sits on the data and owns the data. In blockchain, everyone can do that, yes? But you see that actual metrics of blockchain approximately 2 order of magnitude or even more less than internet. It means that till now, the part of blockchain in internet ecosystem is percentage only, like small, like close to maybe 1 or 2%. And yes, and what are people doing in internet? How we can know that? Except like passing cryptocurrency to each other, what they doing? How we can query that? Yes, in some sense we can query. This query that I built here is the name of events which is most popular in Ethereum. And I built it by year. So this is 2017. What we see here. Of course, there is a like transfer, like what is split, I even don't know. But what you see here, say log new bet, log bet 1, auction started. What it means? It was gaming. It was like bet on smart contracts, like gambling on smart contracts. It was 2017. And later, you will not see it. In 2018, there is no more like gambling, but there are some auction created. By the way, it's the word birth. Who knows what is this birth means? Yes, рождение. Who was born in the blockchain? No. No. Pregnant. It was pregnant and then it was born. You see the pregnant and birth. Who was? Yes, it's CryptoKitty. It was CryptoKitty. Kitty was pregnant and new CryptoKitty was born. And actually, this remarkable that really in 2018, before all this NFT boom that only started last year, CryptoKitties generated significant traffic in Ethereum. It was quite amazing that they did. So they generated new kitties. It was, by the way, auction created probably also related to CryptoKitties. What is interesting in this year, for example, if we take this year, what we will see? We don't see any CryptoKitties, but first of all, almost all these words related to trading of tokens. So transfer approval, you see here the orders match. So for, I think the last 2 years in blockchain is under the umbrella of so-called DeFi, which means that the token are traded, it's used as a bank, it's used as a staking deposit. So people want to generate money just by creating some financial schemas on smart contracts, and it's very visible. So it's visible in the way how they interact by this usage of these methods in smart contracts, and it's quite visible. And this is the same this year, but here I ranked the words not by frequency but by gas usage. Gas usage means how much money people spending to call particular smart contract method, and it shows which method are most important for people. And here, even more evident that bulk execute is also trading. Just the name doesn't tell that, but you see another swap exact ETH for tokens is trading, deposit pending funds trading. Almost all of them are trading. It means that all commission that people pay in Ethereum blockchain is due to DeFi. That's very important outcome. So we see the history by just looking at the data. So when Ethereum just appeared, it was like some simple games, most of them scams. Then it converted to tokens. Then it was popular like CryptoKitties and so on. When CryptoKitties appeared, people had no idea how to create money on Ethereum. And the revolution happens only in maybe 2021, when people realized that DeFi gives the ability to generate revenue on blockchain. And this revenue generation is through trading on smart contracts. Not just trading, they do many interesting things like liquidity pools, margin trading, like what banks are doing. Essentially, it bank on blockchain. What you see here is bank on blockchain. And this is dynamics of DEX trades by date. So you see here tremendous growth of transactions. This is specifically only DEX trades transactions. So the revolution happens here. Until now, it grows, but it grows not because of Ethereum, it grows because of other blockchains again. The Binance Smart Chain appears, everything else. So other blockchains support this growth. Dynamics still going up in this area. And the last thing that I wanted to show is this CryptoKitties story, which gradually converted into so-called NFT boom, that everyone issued NFTs. It happened like last year, even year before, I think it started, 2021. This query shows the dynamics of transfers of regular tokens, which is fungible true. Fungible means that it's measured in some granular units, while non-fungible, they're uniques, and like every CryptoKitty, it has ID. So I created these two queries to compare. And what I see, so this is logarithmic scale. The blue is NFT, the yellow is tokens. So what we see, first of all, this spike is CryptoKitties. So before this moment, there were no NFT at all. You see that number is around 100 transactions only. It's nothing. It's some experimental. After this, it was counted in hundreds of thousands per day. It's quite high. So at this point, CryptoKitties reached the same transfer count as regular tokens. It's quite remarkable. But then the interest, of course, fall. And now we see here in this area, we see the growth of interest to NFTs. And actually, it's quite remarkable that it almost touched the transfers of NFTs like to regular tokens. It's quite remarkable because in traditional finances, we don't see anything like this. We cannot expect that, say, playing cards will be the same as popular as dollar bills. Yes, we never expect that. But for some reason in blockchain, it happens that people believe that these NFTs is the same value as like currency. I don't understand that, but maybe somebody can explain why it happens. I only can see this data and show it to you. It's quite interesting that it actually is. I mean, this boom is real. And this is these kitties that I placed just to show you. You see how I got it. 1, 2, 3 is the number, sequential number of CryptoKitty, which is recorded in the blockchain. But to see the picture, you need to go to website. Unfortunately, CryptoKitties does not record the image itself on blockchain. Okay. At the end, I want to share with you some maybe future ideas. What can we do next? So we just touched the surface because we looked only on very global picture and just selected only some particular spaces. But it's not limited to this type of analysis. Also, I'm sorry that the kind of this doesn't look the same styled as Exness, say, promoted in their presentation. And I'm not very professional in this Jupyter notebook. But we use different tools. I mean, we don't use Jupyter notebooks for our data analytics. We sell APIs. Yes, and we have different kinds of analysis based on this API. So everything that we show on our Explorer is driven by the API. You see this button, Get API, which goes to the API where we get data. Yes, and we have different kinds of analysis, not just only what I've shown. We have, for example, this, for example, is the real-time streaming of the data. It's another kind of analysis. It's fun application that just shows NFT in real time, which is fallen. It's with pictures. Why we show that? Because we want that people will receive the data in the same rate that the data appears on the system. So we combine the data sets that we have in archive. In analysis that we've seen, it's purely archive data. Here we have like different dimension is time. Time matters for blockchain, and we believe that the analytics must be in real time. So we don't just query the database. We also want to see the same data is in. The other thing that probably interesting is that we can query. One way how we query the data set I've shown you is GraphQL that we use. The other way how we query it is using natural language. We have some ideas how to say type the question. What is the DEX address, and it will just answer this question by it found some address and also some list of addresses just by building the model of the data. So this is driven by the model that we built from labels of addresses, from description, from on-chain data, and it can answer the questions that you can write in natural language. So this is just another way of doing this. Thank you very much. I actually shown what I wanted. I think that you can just use, you can find maybe useful to use the project. This one on why blockchain data matters, and you can try to analyze some data yourself.
Let's open Q&A.
Question: If you measure total data capacity of blockchain or any blockchains in terabytes, gigabytes, petabytes, how many data you could store in blockchain?
Currently, we have approximately half petabyte. By the way, there is. I tried to find the same figure for internet. I found figure of 5,000 petabytes by Google, but I think it's outdated. Now it's bigger. So I think that overall blockchain right now is approximately 10 petabytes. It's my estimate. We have approximately 1/2 of petabyte.
Just small silly question on your last plot you showed. There were two peaks actually. The first was on NFT.
Yes.
Two largest peaks. The first one was according to Kitties. So what was about the second one?
I think it was some airdrop. You mean blue on
Which
the?
is higher than token
You mean this one?
Yeah.
You can analyze yourself.
Okay.
I think it's some kind of NFT issuance of airdrop. You know, the peak is very easy to generate artificially. In Ethereum, just by running some bot that will generate like airdrop to million of addresses of one token. It will be each of them will be transfers and it will be reflected in statistics. However, if you count here the unique users of NFTs and tokens, it maybe makes sense to compare.
And second, a little bit wide question. You talked about the internet as a database. So how do you think when and why we will have Web3, some kind of blockchain internet, and do you believe in this? What's up?
I think the blockchain will take part in the internet ecosystem as a database for internet. It essentially will happen for reasons that it's most natural way of consider the information in overall. Because if we talk about these petabytes of Google, we don't feel it them. We don't own the data. We don't use this data. Only Google can use. Yes. And in Web3, what is called Web3? It's decentralized applications, first of all. Yes, so the applications that does not depend on any particular company. And nobody can stop this application, yes? And also, I think the same applies to the data. It's data that not runs by any company, and also nobody can remove the data or like censor the data. Nobody. I mean, if I create a protocol, and this protocol will run, and the government come to me and put me in the prison, even then, nobody can remove this data. This is really Web3. If it doesn't depend on any particular person, organization, whatever. Yeah, so I think that in terms of the data, blockchain will take this part in the internet eventually. Not now. Now we are pretty far from that, but in some future we will see that. Say, in other words, if you will see the data on the website, it will be blockchain data only. So that's what I mean.
Other questions? Everybody is tired. Alexey, thank you so much.
Thank you.
Big applause. Thank thank you everybody for this meetup. One more question, sorry.
Yeah, you said that you have GraphQL interface and natural language interface, but why don't you have SQL?
Oh, this is another hour of discussion. No, in short, I can say that we actually used SQL back when we just started. It was very difficult to integrate with our clients because our business is selling data to our clients. Yes, which choices we had? We could put the data in the cloud. Yes, we could sell API by ourselves. What else? We couldn't open the database to the public internet for apparent reasons. So we selected to use API, and some of our customers actually use cloud storage. They query using SQL.
I mean, it can be not real SQL, but something SQL like you write something in SQL style, and you get the same result.
This question comes to technological discussion. Of course, SQL is also a good choice. Yes, we just selected GraphQL because it looks to us that it's more appropriate at that time. For SQL, we had to implement the parser and the engine which runs across multiple databases because we have multiple data sources. When I query, I don't query just one, I query many. So build SQL that queries many databases, and this will be transparent to the client. It's very hard for me. I don't know how to do that. Another thing that why we use GraphQL is subscriptions. We use Leaf subscription, and SQL doesn't have this feature. And for us, it's also a very important feature that we have real-time data. For SQL, you would have to use something like Kafka plus KSQL or something like in that area, which kind of gray area for internet, because also Kafka is hard to use outside enterprise. Mm-hmm.
Okay, once again, big applause to Alexey.
Thank you.
Thank you so much. Thank you everybody for coming today. I feel like we had a nice journey today. Hope you enjoyed, and see you on the next meetup. Thank you so much.
Thank you.